Hi, Year 13. I hope you're all keeping all okay and doing well during this really difficult period. What I'm going to do with you this week builds on the work that we've been doing in recent weeks and start to consolidate our knowledge and giving us the best possible opportunity of preparing for end-of-year exam and also ahead of January, because we do still hope that there will be some sort of assessment for you guys externally in January as well, although we don't know for sure whether or not that definitely will or won't happen. What we do know is that the final section of the paper has always been focused on this term here, interrelationship links. Interrelationship links we've talked about in lesson on a number of occasions, but not really focused hugely on that, linked to energy system. So the second part of the session is around the energy system and the adaptations. Now you'll know from our lessons that we have the anatomy and we have the physiology. Yeah, we've got the anatomy, the system, the structure, the things that are actually contained within the body, and then the adaptations are being the physiology. Yeah, so the things that happen as a result of exercise. And energy systems are exactly the same, although you'll be pleased to know that there's fewer adaptations for us to learn here. So your work this week is going to focus around this question, and this question came from an exam paper a couple of years ago. Section F you'll see, so section F is the final section, and you can see that title there in interrelationships. So question is about Paula, who's a footballer. She's been doing a training plan, and there is some long-term adaptations to her cardiovascular and energy systems. So your task is to analyse how long-term adaptations of her cardiovascular and energy systems affect her football performance. So what I'm going to do is I'm going to talk through that, answering that question. You're going to answer the question and upload it to me so that I can mark them and give you some feedback on those, please. But that looks like there's 8 marks at the end of the paper. That's what it would be worth, but actually there's a lot of work in terms of us really bottoming out our understanding of energy systems here, but also starting to understand the writing style that's required for these kind of questions. So if I just flick on to the next slide, the question's there at the top, that's the same question. Assessment Objective 5, so this is directly from the specification, and I've showed you this before, but it's important that this is really, really clear in your head. So Assessment Objective 5, you ask to make connections between body systems in response to short-term and long-term exercise. So here we've really clearly got long-term adaptations is what we're talking about here, although that could have been short-term in a different question. In the spec, it asks you to make connections between, or be prepared to make questions between, the muscular system and every other system we've studied, the cardiovascular system and the respiratory system, and then energy and the cardiovascular system. So here we're being asked to do this, aren't we? So energy system and the cardiovascular system is what this question is asking. Now, to answer this question, you're going to have to know what the adaptations are from the energy system. You're also going to have to know what the adaptations are from the cardiovascular system to exercise, but we've done that before. So I'm going to give you a few reminders of that, but we have done that before. So if we are going to analyse how these long-term adaptations affect her performance, we have to know what the long-term adaptations are for Paula. Okay? And like I said, there are fewer of these than other systems, and I've tried to break it down as easily as I possibly can. Now, as ever with BTEC PE, there are others. So if you were doing sports science degree or perhaps in A-level biology, you may be aware of some slightly more detailed content here, but for the sake of your BTEC Unit 1, these are the key facts that you need to know. So I've just done a 6-week training plan. These are the adaptations that would have occurred within my energy system, and I've broken those down into the 3 different energy systems, and I'm not in this video going to give you too much specific information about those because I need you to think about it and apply it to the question. We'll revisit this so that you do have all of that knowledge, but I want here really for you to be able to apply your knowledge and really think this through. So ATP-PC system, one of the adaptations is increased storage of creatine. What is that going to mean for the ATP-PC system? I'm going to leave that with you. If you need me to clarify that for you, come back to me on it, email me through the week. But what does the increased storage of creatine mean for the ATP-PC system? In the lactic acid system, 2 responses we get there. We get an increased tolerance to lactic acid, and we also linked to that a delayed obla. Now, if you remember, obla is onset of blood lactate accumulation, so it's the point at which lactate starts to accumulate within the blood. All right, so the two things there are directly linked. Again, how does that impact on our footballer in the question? And then finally, in the aerobic system, increased number of mitochondria. You need to understand why that's a benefit. If you're not sure of that, come back to me again, but I want you to be able to work through this and understand why the increased number of mitochondria is going to be a positive adaptation. Similarly, increased storage of glycogen. Why is that going to be a positive adaptation? And then finally, the increased ability to use fats as a fuel source. So 2 and 3 are very much linked. So for the sake of this question, we're asking ourselves what the adaptations are. So to be able to answer that question, we need to understand what the adaptations are. So this is just from the last slide. Yeah, so we've just gone through those. What I want you to do is just pause the video, and I want you to, without looking at anything else and without checking your notes or anything like that, how many adaptations to the cardiovascular system can you put down? Yeah, so if this was in the exam question and you'd been asked to list the adaptations to the cardiovascular system following an exercise training period, how many could you get down? Pause the video, have a go, and then we can move on. So hopefully you've paused your video and you've had a crack at that, and I'm hoping that you've at least got 2 or 3, if not ideally more. I'm going to share those with you now just so that we have got them for the sake of this question. Okay, so again, I'm not explaining them. If you need any details from me, you'll need to contact me on that. This is content you should know and should be able to understand and apply. So, adaptation being cardiac hypertrophy, increased stroke volume, reduced blood pressure, reduced resting heart rate, capillarization of skeletal muscle, capillarization of alveoli, and an increase in blood volume. So, armed with all of that information, you should be able to have a really, really good crack at the question. The problem is that the adaptations and the content do give us marks. But if you're going to get the top marks and really into the top band, the level 4 answer, you have to know that content like we've just done, be able to apply it to Paula, which is really, really important. And then the third point, which is a bit where people find the most difficult, is to be able to make comments about the interrelationships between the two. So the interrelationships between the two systems, and that's the trickiest bit of this. Now I'm going to give you one, and I'm going to give you one so that you're on the right track with things. So I'm going to give you a link between the delayed obla and the increase in blood volume. I'm not going to explain that to you. I'm going to tell you that that is a link, and I'm hoping that you will know exactly why that is the case. Again, if you don't, please do contact me, because I want this to be a learning process. That's not just me giving you loads and loads of information. We've got to be able to apply what we know to this question. There are 2 other, what I can see is quite obvious links. There are any number of other links which you may be able to, as you develop your understanding of the systems, see how the two things link together. Yeah, the capillarization of alveoli, hopefully, is an obvious one for you here. Cardiac hypertrophy and stroke volumes, a link here. You would like to think that by thinking about mitochondria, you might be able to get a link across to the other system as well. So there's lots here that I'm hoping you're going to be able to produce a really good answer to that question. So the task is to answer that question, following watching this video, following making some notes, hopefully doing a bit of work to get yourself in a good position to answer that, and then uploading an answer to me, please, on that. Bearing in mind this is the last section of the exam. The exam board always give 2 or 3 pages over to this. It's the most lengthy question in the paper, and it's the marks that students find the most difficult to get. As ever, any questions, get in touch with me and I will help you in any way that I can. Thank you.